Hey everyone, it's Miss Joyce. Today we'll be reviewing adding and subtracting mixed numbers with unlike denominators. Let's start with 2 and 4 fifths plus 1 and 2/3. If we look at the two fractions that we're adding, we can see that the denominators are not the same. This means that the sizes of each parts that make up the whole are not the same sizes. So we need to create equivalent fractions so that the denominators are the same in order to add them. To do this, we are going to write out the multiples of each of the denominators. So let's start with 5, since 5 is the denominator of our first mixed number. We have 5, 10, 15, 20, and 25. Now let's list out the multiples of 3, since 3 is the denominator of our second mixed number. We have 3, 6, 9, 12, and 15. If we look at both lists of multiples, we can see that 15 is the first multiple in both lists. This means that we're going to rewrite each mixed number so that the denominator is 15. So let's start with 2 and 4 fifths. We know the denominator is going to be 15, so let's ask ourselves, what do we multiply by 5 to get to 15? Well, 5 times 3 is 15. So let's multiply by 3 on the top. 4 times 3 is 12. Remember, the 2 in the whole number in front stays the same. Now let's do the same thing for 1 and 2/3. We know the denominator is going to be 15. So let's ask ourselves, what do we multiply by 3 to get to 15? Well, 3 times 5 is 15. So let's multiply the top number by 5 as well. 2 times 5 is 10, and the whole number 1 in front stays the same. If we look at our equivalent mixed numbers, they both have a denominator of 15. So now we can add them together. 2 and 12 fifteenths plus 1 and 10 fifteenths. Let's start by adding the fractions first. 12 fifteenths plus 10 fifteenths is 22 fifteenths. Now we can add the whole numbers in front. 2 plus 1 is 3. So we have 3 and 22 fifteenths. But if you look, the numerator 22 is bigger than the denominator 15. That means there's at least one whole within that fraction that we can take out and add to our whole number 3. So what we're going to do is break apart or spread out our whole number. We're going to take out one whole as a fraction, and then we'll add the remaining fraction. So we have 3 plus, let's take out one whole from this fraction, which is 15 fifteenths. And now let's ask ourselves, what do we add to 15 fifteenths to get to 22 fifteenths? That would be 7 fifteenths. So here, when we add 15 fifteenths plus 7 fifteenths, we get the 22 fifteenths that we had here. But we know that 15 fifteenths is the same as one whole. So we can rewrite it as one whole. Now we can add the whole numbers and fractions together. 3 plus 1 is 4, plus 7 fifteenths is 4 and 7 fifteenths. So the sum, or answer to the addition problem, is 4 and 7 fifteenths. Now let's try a subtraction problem. Here we have 2 and 1/2 minus 3/4. Well, if we look at the two fractions that we're subtracting, we can see that they do not have the same denominator, which means the sizes of each part are not the same. So we need to create equivalent fractions that will have the same denominators. To do this, we'll list out the multiples of each denominator. Let's start with 2, since that's the denominator of our first mixed number. We have 2, 4, 6, 8, and 10. Now let's list out the multiples of 4, since that's the denominator of our second fraction. We have 4, 8, 12, 16, and 20. When we look at both of these lists, we can see that 4 is the first multiple in both lists. So we're going to rewrite each of these fractions so that the denominator is 4. Let's start with 2 and 1/2. We know that the denominator is going to be 4. So let's ask ourselves, what do we multiply by 2 to get to 4? Well, 2 times 2 is 4. So let's multiply by 2 on the top. 1 times 2 is 2. And the whole number 2 in front stays the same. Now let's do the same for 3/4. We know the denominator is going to be 4. So let's ask ourselves, what do we multiply by 4 to get the 4? Well, 4 times 1 is 4. So let's multiply by 1 on the top. 3 times 1 is 3. So now both of these fractions have a denominator of 4, so we can subtract them. Here we have 2 and 2/4 minus 3/4. Always start by subtracting the fraction first. 2/4 minus 3/4 we can't do, because if we only have 2 parts shaded, we can't take away 3 parts. So we need to rewrite this number as a fraction greater than 1. To do that, we are going to multiply the denominator 4 times the whole number 2. Then we'll add the numerator 2. So 4 times 2 is 8, plus 2 is 10. So the numerator is going to be 10, and the denominator 4 stays the same. Now we can subtract 3/4. So 10/4 minus 3/4 is equal to 7/4. But if you notice, the numerator 7 is bigger than the denominator 4. This means there's at least one whole that's inside of this fraction that we can take out. So let's ask ourselves, what can we multiply by 4 to get closest to 7 without going over? Well, 4 times 1 gets us closest to 7 without going over. Because 4 times 1 is 4, we need 3 more to get to 7. So the numerator is 3, and the denominator 4 stays the same. So the difference, or the answer to the subtraction problem, is 1 and 3/4. Now let's try a word problem. Mikey and Chris share blue Takis. Mikey brings in 2 and 2/5 bags of Takis, and Chris brings in 1 and 3/4 bags. How many bags of Takis do the students bring in all? So the words in all tell us that we are combining these bags of Takis to find out the total amount that friends brought in. So that means we are going to be adding the two mixed numbers together. We have 2 and 2/5 and 1 and 3/4. If we look at the denominators, we can see that they are not the same. So we need to create equivalent fractions so that the denominators are the same. To do this, we're going to list out our multiples of each denominator. Let's start with 5, since 5 is the denominator of our first fraction. We have 5, 10, 15, 20, and 25. Now let's list out the multiples of our next denominator, 4. We have 4, 8, 12, 16, and 20. If we look at both lists of multiples, we can see that 20 is the first multiple found in both lists. So that means we are going to create equivalent fractions where the denominator is 20. Let's start with 2 and 2/5. We know that in our equivalent fraction, the denominator is going to be 20. So let's ask ourselves, what do we multiply by 5 to get to 20? Well, 5 times 4 is 20. So since we're multiplying by 4 on the bottom, let's multiply by 4 on the top. 2 times 4 is 8, and the whole number 2 stays the same. Let's do the same for 1 and 3/4. We know that the denominator is going to be 20. So let's ask ourselves, what do we multiply by 4 to get to 20? Well, 4 times 5 gets us 20. So since we're multiplying by 5 on the bottom, let's multiply by 5 on the top. 3 times 5 is 15, and the whole number 1 in front stays the same. So now we have equivalent fractions where both of these denominators are 20. So now we can add them together. 2 and 8/20 plus 1 and 15/20. Remember to add the fractions first. 8/20 plus 15/20 is equal to 23/20. Now we can add the whole numbers. 2 plus 1 is 3. So we have 3 and 23/20. But if you look at the fraction, the numerator 23 is bigger than the denominator 20. So that means we can take out at least one whole and add it to our 3 wholes in front. So let's go ahead and do that here by separating the 3 plus, now this is where we're going to take out one whole from the fraction, which is 20/20. And now let's think, what do we add to 20/20 to get to 23/20? Well, that would be 3/20. So we're just breaking apart this mixed number. 20/20 plus 3/20 gets us the 23/20 that we had here. But we know that 20/20 is the same as one whole. So we can now add these whole numbers together. 3 plus 1 is 4, plus the fraction 3/20 is equal to 4 and 3/20. So that means that Mikey and Chris brought in 4 and 3/20 bags all together. So here's our last problem. It's very similar to what we just did, but the question that's being asked is a little different. It says Mikey and Chris share blue Takis. Mikey brings in 2 2/5 bags of Takis, and Chris brings in 1 3/4 bags. How much more does Mikey bring in than Chris? Well, how much more tells us that we are going to be subtracting to figure out the difference or the answer to a subtraction problem between the amount of Takis that Mikey brings in compared to the amount that Chris brings in. So we've already done the work of rewriting these fractions to have the same denominators. We had said in the previous slide that we have 2 2/5 is equal to 2 8/20, and 1 3/4 is equal to 1 15/20. So we already have the equivalent fractions where both denominators are 20. Instead of adding like we did in the previous problem, we're going to subtract. So let's subtract 2 8/20 minus 1 15/20. Remember, we need to subtract the fractions first. 8/20 minus 15/20. Well, we can't take 15/20 away from 8/20. So we need to rewrite both of these mixed numbers as fractions greater than 1. To do that, we are going to multiply the denominator times the whole number and then add the numerator on top. So 20 times 2 is 40 plus 8 is 48, and the denominator 20 stays the same. Let's do the same thing for the next mixed number. Here, we're going to multiply the denominator times the whole number and then add the numerator. So 20 times 1 is 20 plus 15 is 35, and the denominator 20 stays the same. Now we can subtract 48/20 minus 35/20 is equal to 13/20. So that means that Mikey brought in 13/20 more bags of Takis than Chris.